those of you that were gone on Friday, we pretty much went over homework, and there were quite a few questions. I think we had to finish up a little bit from section 5.3. We did some workspace, I think, right? And we barely got into optimization, so really you haven't missed anything in as far as those except for this. We did talk about how optimization, we haven't really made a forever card out of it because it's just finding the max of the min using critical numbers in a sign chart. First derivative test, would be a sign chart. Second derivative test would be concavity, so a little bit different. Second derivative plug-in, first derivative before and after sign chart values, check the behavior. But we did talk about how they don't always say the words maximum, minimum, maximize, minimize in the problem, just to be aware. We also talked about how clues tend to come up, and we need to be available and ready to figure out the important clues and to ignore the non-important one. And we talked about FRQs last year with bananas and potatoes and people coming on to work after people started buying, et cetera, et cetera. Optimization. All right, Chloe, calm down. Did you steal some of your energy drink?
He did actually. I did, but I'm not excited. I'm excited.
Okay, that's good. I don't fully believe that, but here we go. I said holy. No. I feel like he's telling me what he thinks I want to hear.
I'm telling you the truth.
All right, here we go. Kiddos, this is technically, I want you to still summarize these steps really quickly, just because we didn't make a forever card out of optimization. Every year I kind of am like, should I not? There's only so many I can make, because there's only 50 cards in the pack, and only so much that your brains can hold. And I think the optimization problems that show up in like college calculus classes are not necessarily what's on the AP. The AP literally just wants you to find the maximum or the minimum, maybe absolute, maybe relative, and I figure we have forever cards for absolute and relative. So we do optimization, but basically I just say, hey, look out for things you can plug in, look out for clues, look out for the important information. Look out if you need to use two different equations and put the two together in order to solve. There's not really a forever card in a sense to be able to make out of this. Well, because it's still important.
Yay!
I know, it's a struggle. It's still important. I'm just not labeling it an actual forever card.
Yes. Yes.
Not on my pencil, not seeing getting that one. It's a good pencil too. Oh, there it is. So in the typical optimization problems, which we know the AP is anything but typical, but in typical like textbook optimization problems, there's some quantity that needs to be maximized or minimized. That's the primary objective. Some quantity that needs to be maximized or minimized. That's the primary objective. There's usually, in textbook problems, some sort of other clue, other necessary piece of information that we have to put together. Last year with the bananas, you had bananas being stocked and bananas being bought. I don't remember if that was a max min problem. I don't think it was. Yeah, that's what I was thinking. These integrations that change. But that is trying to remind you guys of the idea that they love to give you information, and sometimes it seems super random. So we have to read out what's most important and how to take all the different pieces and put them together in a cohesive whole that we're supposed to solve. So take the primary, take the secondary. Remember, secondary is just our clue. Something extra. If we can't just derive the primary right away, there must be something else that we can plug in. Check the feasible domain. That just gives us the boundaries to think of, and maybe it'll even help us with sign charts and tables, etc. And then using calculus to find max or min. Well, guys, we've been doing that in the earlier sections, right? With local extrema and with absolute extrema. But in this one, you're usually finding the max. It's usually absolute, but you might still have to think about a sign chart. One more second. We good? Okay, so here we go. In case you didn't know from reading the problem, the title says finding the maximum volume. And we have the following. manufactured, residing, open box, square base, and a surface area of 108 square inches. What dimensions will produce a box with maximum volume? What's volume equal?
X times X times
X times X times H.
X.
Good. Length times width times height. Is that okay? So I want to find the maximum. Let's do V prime. Could we do V prime?
No, yes, no.
We could, but wouldn't we have to do like ddx and then we have this little h over here?
Yes.
And
So for H.
can we take and have dh dx and dv dx? Yes.
So for H.
But is there? Let's take our clue off to the side and let's go ahead and say, well, if that equals 108, then can't I say solving for h? That h equals 108 minus x squared all over, double check my math, 4x? Is that true? Solving for h, subtract the x squared. And if you guys are remembering with surface area, because they don't have to give that to you, it'd be the area of the square, so x squared. There it is. And then you have 1x, this is area. 1x times height would be one of the sides, but you have 1, 2, 3, 4 sides, hence the 4x. So a question or good? We're going to do with this guy?
Yeah.
Let's do it.
And then just 108 X squared minus X to the 4.
If I were you, I would,
Distribute.
well, really?
Well,
I would
yeah.
simplify an x and get rid of them.
Yeah.
But then distribute.
Then distribute 1/4 x.
Wait, what?
Can't I make this x over 4? That's not for time because now it's wrong. I want to bring the 4 out too. And can't I distribute x over 4 to both terms?
Yeah.
So 4 goes into 108 mental matters. 27 times. So I have 27x minus, and then I have 1/4.
X cubed.
See, isn't that a lot easier than a quotient rule?
No.
The x is reduced, so we were able to just deal with the 4. And the dividing by 4 is multiplying by a 4. Divided by 4.
Thank you. Thank you.
You're welcome.
Bye.
But wait, the whole point was to find the max. What do we do? I don't know, it's the whole thing. I had to make it close. Yeah. So v prime is equal to 27 minus.
3 fourths X squared.
No
X is
d and
equal
e,
to
so just that's equal to 0.
27 times 4.
Yeah, subtract the 27.
27 times 4.
Don't do it that way. Do x squared equals 27 times 4/3. Wouldn't that be easier?
Of course, how could I not do it?
Subtract 27 divided by a negative.
Yeah.
The 3 and 27 becomes 1 and
9.
9. Oh,
The negative divided by a
hold on.
negative.
X equals plus or minus 6.
I subtracted the 27 and divided by a negative. Subtract the 27 and then divide by a negative. It cancels out. The negative cancels out. I end up with x squared equals 36, hence x equals plus or minus 6, but they were just having a conversation up here in Kyle and Gabby. What did you guys decide?
Cow's genius.
It's positive because we don't have a negative value.
I'm so
Good.
proud.
Can't be a negative because we're talking about an actual measurement. And so therefore we can take this and say, hence x equals 6. Now what are they asking for? Hold on. Dimension. So if I have x equals 6, my dimensions of max volume. Would be 6 by 6 by, how do I find the h? I have the length, I have the width, how do I find the height?
We have a survey.
6 squared is 36, 108 minus 36 would be 72. 72 divided by 24 would be 3, right? 72 divided by 3. Where are we measuring all this stuff in? Ah, but it wouldn't be square inches.
It's just cube because we're volume.
No, but we're not writing volume, we're writing dimensions.
Oh.
I forget how many tick marks inches are. Is it 2?
No, 2 minutes.
Right?
Take yes.
Tick marks. Like you can say like inches and feet are like 1 tick mark.
Yeah.
But now it's being redundant, so I'll take away all my tick marks.
What's 3 tick marks?
I don't know. Centimeters? Nope, that wouldn't work. Half an inch? Anyway. Kiddos, that wasn't too bad, right? Pause. Why did I not show any wording explaining my math? Why did I do no sign chart?
Because you didn't use them.
I didn't need a sign chart, but why?
There's only one critical number.
Yeah, there's only one critical number. There are no endpoints. And with a cubic function, is it possible for a cubic function to have more than one max? That's one way of thinking about it, but another way of thinking about it is, does this actually say to justify?
No,
Okay,
what I-
well that was nice too. If it did say to justify, then we could have done it one of 2 ways. We could have found v double prime, which wouldn't have been that bad. Or we could have done a sign chart. What do you guys, if we did need to justify, what would you rather do? Second derivative, plug in, or sign chart before we Alright. Actually, that second derivative would be easier. So we have 6, v prime, plugging in 5. 5 squared is 20. Are you sure you want to do a sign chart?
Well, we're already started.
Alright, well then, as you guys are figuring that out, have fun plugging in 5 and 7. I'm going to do the second derivative at 6.
6 or 4 times 6.
I said 10. 100.
Oh, yeah.
I'm even taking a while. You guys.
200 divided by 470. Oh, it's a negative on the other side.
We finished this.
Yeah, we finished.
So it's positive and then a negative?
Yeah.
Perfect. Okay, so whether, pause. Test correction. Come on, focus, you guys. Whether we're doing the first derivative sign chart, positive to negative, that shows a relative max. We could put that in words. But second derivative, plugging in, the second derivative is always negative. Or I should say negative for any positive value of x. Hence always concave down, hence I have a relative max, however you look at it. Alright, now what? Ooh, this is a fun one. Meaning it's not super easy. Alright, I'm walking around. If I see any tests out, I'm going to take them and you're going to have to get late credit because you won't be able to finish. Put your tests away. Ready, set, go. Ready, set, go. Alan, what's up, man?
Did you say that you can't use a sign chart to justify your answer?
Oh, I said, yeah, you're right. I said if we needed to justify, this is the work that you would do. We didn't go through actually writing the words as to what the work showed. So what we showed in the last page for everybody, just clarification, that was not an actual justification, but that is the work that you should have done to be able to lead to the words that would explain the justification. Thanks, Alan.
Does that say XY?
Y equals, oh, XY. I know, it got fuzzy when I tried to blow it up.
What do you see? Why is that
Oh no, why is that right there?
I was trying to hide the wordy stuff. There.
Yeah, answers.
I don't understand.
This is the point xy, that's the point 0, 2. This is the function y equals 4 minus x squared. You shouldn't need the picture to be able to do this.
That's different.
On the last example, we had to find the maximum volume, so we needed to get the volume equation in hopes of being able to derive it and find the max. This one, we need to find the minimum distance, so we need to figure out a formula for it.
Distance.
What is the distance formula?
Square root of y squared. Y2 minus y. Right?
No.
Right? No?
Wait, is it that way?
I was right. Who the heck said no?
Or you could just think Pythagorean theorem,
Oh, and then you plug in
because that would be x and that would be 0. X minus 0 is a squared. And you could do that's y And that's 2. Y minus 2 is b squared. So x minus 0 squared plus y minus 2 squared is d squared. Take a derivative, right? d dx.
Whoa, why did the derivative so simple? Let's simplify first.
You have a clue.
Ah, there's a clue. Abuse them.
I'm so proud of
Me
you.
too.
God.
Learned a lot.
Smile. What a beautiful man.
So now we have b equals the square root of x squared plus 4 minus x squared minus 2 squared. I was careful with my signs. Nothing got killed in the process of that. 4 minus 2 is 2.
2 minus x squared. So it's negative x. So x to the 12. Minus. Simplify. 4 minus 3x squared.
Double check math, but I think I have x to the 4th minus 3x squared plus 4.
Yes. Whoa. Yes,
Oh man, we haven't even found a derivative yet.
man. Not yet.
Why are you plugging in 0?
0 will just give you 0.
Wait, we have to take a derivative. What are you guys doing? We have to take a derivative, right? Question. Do we want to take a derivative as is with u to the 1/2 power?
Yes.
Or
Or.
do we want to remember that the minimum d is the same, or will occur at the same place as the minimum d squared?
Hmm?
True.
No one's
Last
the only one
year-
who understood that.
Last year,
What'd you say?
I'm repeating,
Yes.
we talked about how the lowest distance will be the same thing as the lowest, or will happen at the exact same time, or at the exact same point as the minimum square of the distance.
What?
Okay, so if 5 is lower than 8 is lower than 11, isn't 25 lower than 64 lower than 121?
Yes.
So the lowest value will also have the lowest square.
Oh, okay.
Why is that nice? Do I want to take a derivative of 1/2 power? I mean, I guess we could.
Yes.
But we could also say, hey, who is
Plugging
he squared?
zeros
Let me
on
just
that
find that min. Who is he squared? Let's just find that min.
Then you have to do d.
Let's do d squared prime. We'll just be lazy.
Oh, but it's
And we have 4x cubed minus 6x. So that equals 0 for our critical numbers. Pull out an x. True? Oh, we could do that. We get 2x squared minus 3. Careful. Plus or minus square root, right? So x equals 0 or plus or minus square root of 3/2.
It's equal to the square. Look at the square root.
Doesn't it have to be positive?
Well, but points on a graph, though, I guess they could be negative, right? Here's the question, though. Which one is the minimum? Could one of these be the maximum? Maybe we should justify them. You guys want to do the first derivative?
Yeah.
Alright.
Well, do we have a second root?
We could find it. It'd be 12x squared minus 6. Well, we have to plug in plus or minus root 3 over
Let's
2.
just do the third derivative.
But then the square will cancel out the square.
Yeah, let's just do the jerk.
That's true. Second derivative? Okay. So then d squared double prime would be 12x squared minus 6, which would be 6, 2x squared minus 1, which would be, well, I guess you probably don't want to factor that anymore, huh? Who are we plugging into that second derivative? Why 1? Don't we want to plug in 0 and plus or minus root 3 over 2? Oh, it's 3 over 2, sorry. I'm distracted by my really messy square root.
You're forgiven. Katrina, hit me up.
Plugging in 0, we get a negative, right?
Yeah.
Ooh, which is the maximum. True?
Yeah.
Because a critical number where the second derivative is negative, wouldn't that be a relative max?
Mm-hmm.
What am I looking for? Min. So forget that guy. He's a no. And I would describe it as, well, he's a relative max. That doesn't work. But then as I plug in plus or minus, the nice thing is with either one, you get the same answer. Because when I square it, the sign doesn't matter. And then 3 over 2 times 2 would just be 3. 3 minus 1 times 6. Long story short, positives. What does that mean? Alan did catch me on the fact that I didn't actually explain in words last time. So, since d squared prime of plus or minus square root of 3 over 2 is equal to 0, and why did I need this? What characteristic is this proving? Critical number. No. I'm proving critical number first. And d squared double prime of plus or minus root 3 over 2 is less, nope, greater than 0. The minimum distance occurs at, doesn't it say which points? The x's are not enough. We also need the y's. If we go back to the original function, if I square, I would end up with 3 halves. Once again, the plus minus doesn't matter because the square will make them both positive, and then it being subtracted. 4 minus 3 halves, 8 halves minus 3 halves, 5 halves. Careful, the negative isn't squared. This is squared first, then it's subtracting. So 4 minus 3 halves, aka 8 halves minus 3 halves would be 5 halves. That's not even taking a derivative of e to the 1 half. Man, we missed out. Katrina.
Why would you have to write plus or minus if it doesn't change like after?
Well, it says which points are closest, so technically there are going to be points on either side. I guess we could have almost done a positive since they just showed this guy and showed that he would have a symmetric point on the other side. But I decided when they said which points that I would show them.
Yay.
Ooh.
Yeah. Oh.
Right there. Question. Does it make sense that profit is revenue minus cost? We haven't done econ yet, that's next semester.
Yeah.
Profit equals revenue minus cost?
Yeah.
Okay, cool. So if they give us a function for revenue, this is like business calc. Who's taking that right now? Oh, Lucas. Lucas taking business calc. Business calc, this would be like a super basic example. Your question is? Kelly was answering somebody who was asking a question. Ethan, what's up?
Ethan.
I was asking her what does revenue mean.
No, it's a good question. So profit is you're making money, right? Revenue is how much money comes into like a business. Cost is how much they're spending on their products, on their staff, on rental for their buildings, things like this. So this is all the different costs. So like if Mrs. Leon with her pretzels, right? Okay. Revenue is just the money that kids pay her, or like the farmer's market. So it's the money she gets, but she has to pay for the pretzels. She has to pay for products for growing the chili. She has to pay for the packaging. Does that make sense? So cost is what she has to spend. Revenue is what comes in. Subtract the 2, and that's the profit. Good. No, it's a good question. I'm glad you said something. So then, how do I maximize profit?
Raise revenue and lower cost.
You'll be given something like R of T probably minus C of T. It might not be T, it might be N for like the number of product. But T might be time also, just depends. But if we did it like this, we could say, okay, to maximize, don't we need to go ahead and find P prime, right? By taking R prime minus C prime to So they give us a function for revenue and a function for cost, because usually it's pretty complicated to figure out something other than a small business. Even a small business, there are so many little things to buy, to purchase, that go into your product. But still, critical number, I said equal to 0, right? So when is the maximum profit going to occur?
When revenue is high and cost is low.
When R prime is equal to C prime. That's it.
Oh yeah, because you take one another and subtract it to this.
I mean, you will make more money as the revenue goes up and the cost goes down. That's true. But in general, your profit is going to be a max when your R prime is equal to your C prime, when the rate of change of your revenue is equal to the rate of change of your cost. Just based on the trend and based on the curve, et cetera, et cetera. Now you could also test the endpoints. It depends. Like maybe if they give you like a initial cost, final cost, those sorts of things. But I don't think they actually explicitly in the problem give you this. They just say, hey, here's revenue, hey, here's cost, maximize profit. I want you guys to realize, oh, to even work with profit, I need to think about subtracting, and then I can take the derivative and solve. No.
That also gives you the minimum profit.
True. I should just say external. Because then you would have to do, like always, you have to do your first derivative test or second derivative test, right? Sorry if I didn't explicitly say that. That gives you candidates for your external. There we go. Plus the endpoints. And you can also think about it as, well, the zeros of profit would be when your revenue equals your cost, right? Which is what you hopefully don't want, but sometimes it's better than going in the red. That is negative profit, which is sometimes how you have to start before you get a positive profit, but that's why starting a business is so hard.
And then you go on Shark Tank and have people invest like Mark Cuban.
Well, Blockbuster was great in its time, because there was this thing called Netflix and online streaming. Although, there are times that I wish there were still Blockbusters. Like, oh, I really want this movie and there's no way it's at Redbox. I have to rent it from Amazon.
Well, this thing called 1, 2, 3 movies.
I guess you can rent it. Huh?
You can always just illegally stream it.
1, 2, 3 movies.
It's not worth it.
Alright, kiddos.
No, I said that too. I couldn't find those two.
You guys want to write down your homework?
Yes, ma'am. I
Alright.
do. Nothing will make me happy.
Let's see what's going on. Nothing.
Misty, the
Nothing.
biggest number wrong.
I know, I'm going to fix that. I figured that out with the shade that you were throwing this weekend.
Disappointing.
Did you guys hear about Katrina's shade this weekend? The shade you were throwing?
What'd you do? What'd you do? You shook?
No. Shade.
Shade?
Yeah.
She was throwing shade.
Oh.
Because we made fun of her for writing down the wrong problem numbers, but the homework sheet was misnumbered.
Woo!
So,
How about you play like
wait.
Junior Wait, Katrina?
So did we do
No, you guys were right. But hold on, you'll understand when you see it.
I just go by what's at the bottom.
I noticed that the homework number was missed.
Yeah.
This number.
Yeah.
Okay, apparently someone was confused about something, but I'm not.
It's okay, I'll show you.
We did the right problem.
Yeah. You guys did the right problems. Here's the dilemma. Do you guys see how there's homework 16 and homework 16?
Whoa!
I just copied the second. That's the typo.
I know, I
Wait,
apologize.
we're in 5.4.
So Katrina knew she was doing homework 16 and she accidentally started writing those numbers instead of the others. So this is actually homework number.
I'm so proud, Katrina.
Thank you. I'm gonna make Katrina redo her work as if you do all right.
It was only 3 problems. And I signed off that she was okay and that 2, 5, and 9 count as 3, 6, and 7.
So technically, if I do the first one, I can
You can make a mistake.
What?
I like if I did.
Oh, I make you line them up. Meaning you couldn't do just these. I'd make you fill in all the others to make it equivalent. Wait, did you do the wrong assignment?
No, I did it right. To make
Oh.
sure. I did it.
Okay. So guys, let me change the board. It's homework number 17, section 5.4. Okay, since there is no 0 period tomorrow,
What? Why? Oh,
it's Tuesday.
Wow.
Here you go.
What I mean is you guys can't work on test corrections. Why are you guys all pulling up? You have 5 minutes. I'm pulling up the book if you want to start homework. However, if you want to ask each other or me questions on test corrections, I will let you do that as well. But I am pulling up the book as well. Homework starts at 2:59. Okay.
How do I
Yeah. Donut.
You always think of it as
No. Yeah.
Are you serious?
If I'm already right here.
okay. You can think of it as a secret.
P.S. When is our next test?
Friday? Tuesday.
Calendar. Look on the board.
Thursday, Wednesday, Tuesday, Wednesday, Tuesday.
Next Tuesday.
Next Tuesday.
Why is everything red? What other things? Did I see the word?
What? You're out?
Oh, that's the school stuff, like the candle fundraiser, mixed Christmas trees.
Okay. See, it's October.
I know. When did that happen, Ken?
I have applications to finish.
I know.
Sorry. I was thinking it's like he's trying.
I have applications to start.
Okay, hopefully I have and now I'm good. Corey, so it's
Well, your book's not loading. Sorry, guys. I'm really trying, but.
just you guys walk by the door.
Oh, because and then the track. You don't have to write down that's it.
Or you think of it as secret.
No, you just put in your transfer. I'm testing it and thank you.
I still gotta take my second test.
What?
it's not over until
Your second one?
That's what she said. She said 31 you came.
Excuse me? I have a question on 14.
I'm trying to get in there.
Yeah, even though I'm not going to be so, she said why not take it out.
Wow.
Strawberry.
What's she going?
Strawberry.
So you were doing well here. Just switch X and Y, take the derivative, divide 1/6y, right? Once you switch, you're talking about the inverse now. So when you have dy dx equals 1/6y, don't take the x, take the y. So
Are you going to
1/6
put on
times
the
2
book?
would be 1. So you had to solve for dy dx.
Yeah,
So it was 1/6y, not x, 6y.
For number 12, so I did everything here. How do I simplify this thing to that?
Wow. Everybody complaining about their test scores that are like.
Because you probably
Why are you
that,
smiling?
and you probably would be on top, so how do I simplify?
You also have this one down here though.
My other
Is that x to the 8?
Yeah.
Okay. So you would need to do.
Okay, because I didn't know to do the classification, so I took like the one where it changed. You see all of it?
Your ball is
I was like, what?
Welcome to college.
Kyle's never been to
And then square root of x to the 8 is x to the 4. And then that cancels that. Bye guys.
I can tell
Makes sense
exactly.
because the square root will come out and then those two simplify. And then you have negative 4, is that right? X to the 8 for this one?
Yeah.
D. Good mother.
Oh, now the book works. Oh well.